Hey everyone, and welcome to another deep dive with us. Today we'll be taking a look at the world of machine learning algorithms and techniques.
Sounds exciting.
It is.
This one.
Yeah, it covers a wide range of topics from predicting pandemics and optimizing farming to AI and the legal system and everything in between.
There really is so much going on in machine learning these days, it can be hard to keep track.
That's why we're here, to break it all down and connect the dots.
Exactly. Looking forward to it.
All right, let's jump right in. Chapter 1 of this book talks about the transition from cloud to edge computing, which is a big shift happening in data management right now. It's called big data computing, transforming from cloud computing to edge scheduling perspectives review.
Yeah, that is a big shift.
So you know how there are public clouds like Google Drive? Well, things are getting even more specialized now with private, specialized, and even community clouds.
The way things are evolving is fascinating. Cloud computing is like having one central brain handling everything, which works fine in many cases. But imagine you're using a real-time app on your phone, like a navigation app.
Okay, yeah.
And every action requires sending data to a remote server and waiting for a response. That creates latency or delay.
Ugh, I hate latency.
It's a major bottleneck.
So is that where edge computing comes in? Bringing the brains closer to the action, so to speak?
Precisely. By processing data closer to the source, you eliminate that lag and get faster responses. It's like having a mini data center right there on your phone.
Oh, okay. That makes sense. But how do they manage all these mini data centers alongside the big cloud brain? It seems like it'd get pretty messy.
That's the challenge researchers are working on right now, optimizing how tasks are scheduled between those cloud and edge layers. The goal is to ensure that data is processed as efficiently as possible.
I bet that's a tough problem to solve.
Oh, it is. And to make it even more complex, some researchers are using something called extended short-term memory, or LSTM.
Short-term memory, like AI that remembers things.
Well, it's not exactly like human memory,
Okay.
but LSTM is a type of recurrent neural network that can process data and learn from past patterns. It uses specialized memory cells and gates to remember important patterns.
So it's like an AI traffic controller that's always learning and optimizing data flow. That's wild. But this AI isn't just in data centers, right? Chapter 2 focuses on decision-making in the field of unmanned aerial vehicles. State-of-the-art. So we're talking drones.
We are. This chapter is all about autonomous mobile robots, particularly those UAVs you mentioned. We're seeing them used more and more for surveillance, intruder detection, and package delivery.
Yeah, drones are everywhere these days.
Yeah.
But their range and battery life still seem to be big limitations.
They are, particularly for single UAVs. But that's where it gets really interesting. Researchers are now exploring networks of UAVs to overcome those limitations.
A network of drones.
Yeah, imagine swarms of drones communicating and coordinating their actions like a team of tiny explorers.
Like a hive mind.
In a way, yes. They share two types of information: data about their environment and data about themselves, like their battery level. This allows for joint decision-making, where they act as a collective intelligence.
That sounds straight out of a sci-fi movie. The book also talks about a centralized decision-making approach. How does that work?
In that approach, there's a central control unit that issues commands to each drone in the network, kind of like a mission control center.
Oh, interesting. But let's move on to something that's been on everyone's minds lately. The COVID-19 pandemic. Chapter 3. A brief study on understanding and handling COVID-19. Test bed for forecasting with deep learning and machine learning algorithms. Looks at how AI modeled the spread of the virus.
It's a timely topic for sure. Researchers used a bunch of different machine learning models to try and predict the spread of COVID-19.
I bet. Including that exponential smoothing technique they mentioned.
Yeah, that's one of them.
Can you explain that one?
Sure. Imagine you're trying to predict tomorrow's weather. You could look at historical weather data, but what happened yesterday is probably a better indicator of tomorrow's weather.
Yeah, makes sense.
Well, exponential smoothing gives more weight to recent data points when making predictions.
So it's like using the most up-to-date information to stay ahead of the curve. The book also mentions the SIRD model. What's that all about?
It stands for susceptible, infected, recovered, and dead. It helps estimate the virus's reproduction rate and project how many people might get infected. They combine that with other models, like regression and neural networks.
Sounds complicated. Were those models accurate?
Predicting a pandemic is incredibly challenging. One of the hurdles was something called the root mean squared error. Basically, it measures how well the model's predictions match the actual data.
So how well did they match?
Well, there was a high degree of error, partly due to the exponential nature of the pandemic's growth. It was a moving target, constantly accelerating.
Makes sense. Speaking of moving targets, let's switch gears to agriculture. Chapter 4, Ag Tech. Using sensors and machine learning to revolutionize farming practices, IoT, explores how technology is transforming farming.
It really is. This chapter is all about using sensors and machine learning to optimize farming practices, giving farmers better tools to manage their crops.
Okay, so what kind of sensors are we talking about?
All kinds. Sensors that can measure things like soil moisture, nutrient levels, temperature, humidity, even the presence of pests or diseases.
Wow, that's a lot of information. What do farmers do with all that data?
That's where machine learning comes in. The algorithms can analyze the data and give farmers actionable insights.
That's like a personal agricultural advisor, always crunching the numbers.
Exactly. It's not just about optimizing things like irrigation either. They're using the NDVI index, which measures plant health based on how plants reflect light.
I see. So are they also looking at things like soil pH and nutrient levels?
All of that. They even have a no-IR camera, which takes pictures and videos of the plants and sends that data to the cloud.
The cloud.
Yeah, it acts as a central hub for all that data from multiple farms, allowing for large-scale analysis and the development of more sophisticated models. It's like having a global agricultural intelligence network.
That is amazing. But let's move on to something a bit more controversial. Chapter 5, which dives into AI in the Indian judicial system.
Yeah, that's a fascinating one. It looks at how AI is being used to assist judges, especially with things like bail and parole hearings.
So how is AI actually being used in those situations?
Mostly for risk assessment. The AI algorithms analyze a ton of data, including the defendant's criminal history, demographics, and details about the case to assess things like the risk of reoffending.
So it helps the judge make more informed decisions.
Right. It's about potentially improving fairness and consistency in the legal system. The chapter also talks about the e-court project in India.
What is that?
It's a huge initiative to digitize court procedures in India and create a digital infrastructure for the legal system.
That's a massive undertaking. Are there challenges with a project that big?
Many. The chapter highlights things like limited understanding of AI, the need for more training, and of course, data privacy and security concerns.
Those are all big issues. Speaking of big issues, Chapter 6, Analysis of Deep Learning Methodologies for Handling Non-Medical Big Data and Very Limited Medical Data with Feature Extraction and Annotation Techniques, looks at the challenge of limited data in medical AI.
It's a major challenge. We need tons of data to train reliable AI models for medical diagnosis and treatment. But getting large medical data sets is difficult and expensive because of privacy concerns and regulations.
So how do they deal with that lack of data?
By leveraging non-medical data to boost the performance of medical AI models.
So they're using data from outside the medical field to help diagnose and treat medical conditions.
It's called transfer learning. Imagine training a model on a massive data set of images, like ImageNet, which has millions of images from every category you can think of. That gives the AI a basic understanding of visual patterns. Then you fine-tune that model on a smaller medical data set.
So it's like giving the AI a head start, teaching it about image recognition in general before focusing on medical images.
Exactly. It can drastically improve performance even with limited medical data. The book even mentions using ImageNet to train a model for breast cancer anomaly detection.
Wow. What other kinds of medical data are they exploring?
They mention all sorts of data like CT images, MRI brain images, and even gene expression data. It's all about pushing the boundaries of what AI can do in the medical field, even with limited information.
So fascinating. But we can't talk about AI without talking about cloud computing, which underpins a lot of what we've been discussing. Chapter 7 dives into the importance of security in cloud computing, particularly with the rise of virtualization.
Virtualization allows you to create multiple virtual machines on one physical server, like dividing one computer into multiple compartments. It makes things more efficient, but it also comes with new security risks.
Oh yeah, I can see how having multiple virtual machines on a single physical server could create vulnerabilities.
Like having multiple apartments in a building, you need to secure each apartment, but you also have to secure the building itself.
So what are some of the security risks with virtualization?
Unauthorized access, unsecured interfaces, outdated software, and even data leakage between those virtual machines.
Yikes, that sounds like a mess.
They stress the need for a multi-layered approach to security, with things like strict access controls, strong authentication, and constant system monitoring.
That does make me feel a bit better. But it's not just about securing the cloud, right? We also have the Internet of Things with all its security challenges. Chapter 8, Security breaches in IoT applications. An extensive study explores that.
It's another crucial area. As more devices connect to the internet, the risk of security breaches keeps growing.
I can imagine. So how do they categorize the security vulnerabilities of these IoT systems?
They break it down into 3 layers: application, network, and perception.
3 layers, each with its own set of vulnerabilities.
Exactly. At the application layer, you have attacks targeting the software that runs the IoT devices.
So like if someone hacked into a smart home system and unlocked the doors remotely.
Yeah, things like that. At the network layer, they could attack the communication channels. Think denial of service attacks or man-in-the-middle attacks.
And what about the perception layer?
That's where sensors and actuators are. Attacks at this layer might target the sensors themselves, trying to manipulate the data or disrupt their operation. Imagine someone trying to mess with the GPS data on a self-driving car or tampering with temperature sensors in a factory.
Now that is scary. So how can we address all these security threats in the IoT?
AI and machine learning can play a role by analyzing device behavior patterns. If the AI learns what's normal for a device, it can spot anomalies that might be an attack.
It's like having a security guard who knows everyone's routine and can tell if someone is acting suspicious. What else can AI do?
It can automate responses to security threats. For example, if it detects an attack, it could automatically isolate the affected devices or alert human security teams.
So it's both a detective and a first responder. That's pretty amazing. But let's step away from security for a moment and talk about something more personal, our health. Chapter 9 explores AI in healthcare, specifically how AI is being used to diagnose heart arrhythmias.
This chapter gets into how AI can analyze those electrical signals from the heart, the ECG readings. Traditionally, doctors would visually inspect ECGs to look for patterns that might indicate arrhythmias. Now, AI is being used to automate that process.
That sounds like a huge help to doctors. But how does AI analyze those signals? It's like deciphering a secret code.
The first step is cleaning up the signal to remove noise, like muscle activity or electrical interference. Then they use techniques like feature extraction to find those patterns and characteristics that indicate different arrhythmias.
So it's like cleaning up an old recording to isolate the speaker's voice, and then looking for specific words or phrases.
That's a great analogy. And then those extracted features are fed into a machine learning algorithm that's been trained to classify those different types of arrhythmias.
It's like training an AI to be a cardiologist. What types of algorithms are they using for this?
This chapter specifically mentions KNN, which stands for K nearest neighbors, and PNN, which is probabilistic neural network.
Okay, those are some complicated names. Can you break them down for us?
Sure. KNN is a simpler algorithm that looks at the K nearest neighbors to a new data point and classifies that new point based on how its neighbors are classified. It's like saying, if most of your friends like a certain movie, you're probably going to like it too.
I like that. What about PNN?
PNN is a bit more complex. It uses probability distributions to classify data points. It calculates the probability of a new data point belonging to each class and assigns it to the class with the highest probability, so it's more statistically based.
Got it. How well do these systems actually work in diagnosing heart arrhythmias? Are they as good as human doctors?
That's a question that's still being explored. The chapter emphasizes how important it is to use a clean signal, free of noise. Otherwise, the AI can misinterpret the data. And of course, they need a lot of high-quality data to train those models effectively.
It's like anything else, garbage in, garbage out. But it's exciting to see how AI is being used to tackle such a complex and critical aspect of healthcare. Let's shift gears now and talk about remote sensing. Chapter 10 looks at how machine learning is being used to analyze data from things like satellites.
Remote sensing is all about gathering information about the Earth from a distance. It's used in environmental monitoring, disaster response, urban planning, and so much more.
It's like having a bird's eye view of our planet. What kind of data are they analyzing?
They talk a lot about multispectral data, which is data collected across multiple wavelengths of light.
Oh, wow, okay.
Analyzing that data can help identify different types of land cover, like forests, water, urban areas, and agricultural fields.
I see. So how does machine learning help analyze that multispectral data?
They use different classifiers, which are algorithms that put data points into groups based on their features.
So in this case, the classifiers would help identify things like what type of land cover a particular area is.
Precisely.
And what kinds of classifiers are they using for this?
They mention a bunch, including maximum likelihood, Mahalanobis distance, neural networks, random forest, and support vector machines.
Those are some mouthful names.
It's a whole toolbox of different algorithms for analyzing remote sensing data. But let's get down to earth for a moment and talk about something a bit more grounded. Power lines.
Power lines.
Yeah. Chapter 11, Overhead Power Lines Detection Using Deep Learning Approach, is all about using AI to automate the inspection of power lines.
That sounds important, especially since inspecting those lines manually can be dangerous.
Exactly. Think of drones equipped with cameras and AI that fly along the power lines and spot potential problems.
Okay, so how does the AI actually find those power lines in the images? They must blend in with the background pretty well.
They're using convolutional neural networks, or CNNs. They're trained on lots of images of power lines to learn how to identify those features, even in complex backgrounds.
It's like giving the AI X-ray vision for power lines.
That's a great way to put it. One of the challenges they talk about is the need for lots of labeled images to train those CNNs effectively. They need to show those power lines under all kinds of different conditions.
Of course, they need to see all kinds of examples to learn properly. But the potential benefits are huge, right? Safer inspections, early detection of problems, and maybe even preventing power outages before they happen.
Absolutely. It's a great example of AI being used to make our infrastructure safer and more reliable. But let's move from power lines to robots.
Robots.
Yeah. Chapter 12. A survey of path planning algorithms for multi-robot navigation in an unknown environment delves into the world of robot navigation.
That sounds like a classic AI problem, teaching robots how to find their way around.
What are some of the challenges they face?
Well, especially when dealing with multiple robots, you need to coordinate their movements so they don't collide. Plus, they often need to navigate unknown environments where they don't have a map.
Oh, right. They need to be able to adapt to unexpected obstacles and things like that.
Exactly.
So what are some of the path planning algorithms they use?
They talk about several classic algorithms like Dijkstra's algorithm A and RRT, which stands for Rapidly Exploring Random Tree. And they even discuss approaches inspired by nature.
Nature.
Yeah, things like ant colony optimization algorithms.
Ants.
It's all about swarm intelligence. Ants can find the shortest path to food by communicating with each other through chemical trails.
Wow, I never knew that.
They're constantly reinforcing the paths that lead to food, and the colony as a whole acts like a decentralized intelligence.
That's incredible. So are researchers trying to apply that to robots? Exactly. They're developing algorithms that allow robots to communicate and coordinate their movements in a similar way.
That's fascinating. They can also use those optimization techniques they mentioned.
Yeah, those help fine-tune the paths generated by the algorithms. They can minimize energy consumption or travel time, for example. It's about taking a good route and making it even better.
Clever. But let's get back to healthcare. Chapter 13, Pneumonia Detection. Using deep learning and TensorFlow looks at how AI can be used to detect pneumonia.
Chest x-rays are commonly used to diagnose pneumonia, but it takes a trained eye to read those x-rays accurately. Now AI can help automate that process.
That's great. So how does it work?
They use deep learning models, those convolutional neural networks we talked about earlier, to analyze chest x-rays and identify those subtle signs of pneumonia.
It's like training the AI on thousands of examples of what pneumonia looks like on an x-ray. What kind of models are they using?
One they mention is VGG16, which has been really successful with image classification tasks.
So it's a rock star in the image recognition world.
You could say that. They use transfer learning techniques to adapt it specifically for pneumonia detection.
And they talk about developing user interfaces for the model and using Docker to deploy it.
Exactly. The user interface is about making it easy for doctors to use the AI, upload an x-ray and get the results in a clear, easy to understand way. And Docker makes it easy to deploy that model anywhere, like shipping a mini lab in a box.
I love those analogies. But let's move on to something that seems simple on the surface. Recognizing handwritten digits. Chapter 14, Handwritten Digit Recognition. Using deep learning on MNIST data explores this task, which is still surprisingly difficult for AI.
You'd think it would be easy, but it's more complex than it seems.
Why is that?
Everyone's handwriting is different. Sizes, styles, levels of neatness. It makes it tough for algorithms to accurately recognize any digit, no matter how it's written.
That's true, my handwriting is terrible.
Well, this task has been a benchmark problem in AI for a long time. It's a good way to test different algorithms.
So what kind of algorithms are they using for this task?
They're focusing on deep learning, particularly convolutional neural networks, or CNNs.
CNNs are popping up everywhere.
They're really good at this type of image analysis. They learn to extract features from images that are relevant to the task at hand.
So in this case, they'd be learning to see the difference between, say, a 7 and a 9.
Exactly. They use this data set called MNIST, which has thousands of images of handwritten digits. It's like a crash course in handwriting for the AI.
And are they using that Atom Optimizer we talked about earlier?
They are. It helps train the CNN more efficiently. What's really amazing is that they were able to achieve 99% accuracy in classifying those handwritten digits.
Wow, 99%. That's incredible. So they're pretty much as good as humans at reading handwriting now.
Pretty much. But let's move on from digits to a much richer form of communication, sign language.
Sign language.
Yeah, Chapter 15, Sign Language Recognition, using deep learning, looks at how AI can be used to help deaf and hearing impaired individuals. They talk about two main approaches, sensor-based and vision-based.
What's the difference?
Sensor-based approaches use wearable sensors, like gloves with motion trackers in them, to capture the signer's hand and finger movements. Vision-based approaches use cameras.
So cameras would capture the signer's movements.
Right, and then computer vision algorithms analyze the images.
So it's like choosing between a close-up, tactile approach with sensors or a broader visual approach with cameras. What are the pros and cons?
Sensor-based is usually more accurate because you're getting really precise data about the hand movements.
Makes sense.
But it does mean the signer has to wear that specialized equipment.
Which could be inconvenient?
It can be. Vision-based approaches are definitely more flexible because you don't need any special gear.
That's good.
But those algorithms have to deal with things like variations in lighting, background clutter, even what the signer is wearing.
It sounds like a trade-off between accuracy and practicality. But either way, analyzing sign language with AI must be really complex. What kind of algorithms can even handle that?
For vision-based sign language recognition, they're using those convolutional neural networks again.
CNNs keep coming up.
They're just really good at analyzing images and finding patterns. In this case, they learn to recognize those specific hand shapes, movements, and facial expressions that make up different signs.
So it's like teaching AI to see the language.
It really is. They train those CNNs on huge data sets of images or videos of people signing. Each image or video is tagged with the corresponding sign.
So the AI learns what each sign looks like and can start recognizing them in new images or videos. That's incredible.
It is. It really shows the potential of AI to make communication more accessible for everyone.
I completely agree. But let's shift gears a little bit and talk about something fun. Gaming. Chapter 16 is called NFT Games, exploring the convergence of blockchain technology and gaming, which sounds like a fascinating mix of cutting-edge tech.
It is. This chapter is all about the rise of those NFT games, which use non-fungible tokens, or NFTs, to represent in-game items, characters, or other assets.
NFTs are so hot right now. Can you remind us what makes them so special?
Sure. NFTs are digital assets that are stored on a blockchain, which is a decentralized and secure digital ledger. What makes them special is that they're non-fungible. Meaning they're unique and can't be swapped for something else of equal value. They're one of a kind, like a rare trading card or a piece of art.
So instead of having a digital copy, it's like owning the original.
Exactly. And because they're on a blockchain, the ownership is verifiable and transparent, which is perfect for representing ownership of in-game assets.
So how are NFTs actually being used in games?
Imagine playing a game where you could buy, sell, or earn NFTs that represent unique weapons or armor for your character, or virtual land that you can own and develop, or even playable characters.
So it's like virtual items, but you actually own them, not the game company. Why is that so appealing to people?
Well, one reason is true ownership. In traditional games, even if you spend hours and hours earning a rare item, it's not really yours. The game developer can just take it away or shut down the game entirely.
Yeah, that's true.
But with NFT games, you actually own the NFTs that represent your in-game stuff. You can trade them, you can sell them, you could even use them in different games that support the same NFTs.
It gives players a lot more control and freedom. What about game developers? How does this benefit them?
Well, NFTs offer new revenue models for game developers. They can earn royalties every time one of their NFTs is resold. They can also design more immersive and engaging gameplay, taking advantage of the unique characteristics of NFTs.
So it seems like everyone wins. What are the challenges, though?
Oh, there are definitely challenges. The cryptocurrency market is volatile, which can make the value of those NFTs go up and down wildly. Plus, blockchain technology is still complicated for a lot of people. And then there are always those concerns about scams and security breaches.
It sounds like a promising but still risky area. Speaking of game development, Chapter 17, Design and Development of 2D Space Shooter Game and Arcade Game Using Unity, gets back to the basics of how games are actually built.
Yeah, this chapter is great for anyone interested in making games. Unity is this super popular game engine that's used for all kinds of games. This chapter walks you through building two classic genres, a 2D space shooter and an arcade game.
I love those classic games. What are some of the key things they cover in the chapter?
Everything. Game mechanics, creating assets, writing the code, testing the game, collision detection, player movements, power-ups, sound effects, music, visual effects, and level design.
Wow, that's a lot. What are some of those key Unity features they talk about?
Well, there's the Unity editor, which is the main program you use. They also talk about the different views in Unity. The scene view, which lets you see the game world, the game view, which shows what the player sees, the hierarchy window, which lists all the game objects, the inspector, which shows the object properties, and the project window, which holds all your assets.
So it's like a virtual game development studio. What about the creative side of things? How do they go about designing the games?
They really emphasize starting with a clear vision. What are the core mechanics? Who is your target audience? What's the overall look and feel you're going for?
It's like making a blueprint before you start building.
Exactly. And they talk about the importance of prototyping, which is building a simple version of the game early on so you can test out your ideas.
Great idea. And once you've built the game, how do you get it out there for people to play?
You need to test it first, make sure it's fun, engaging, and free of bugs. Unity supports lots of different platforms like PCs, consoles, mobile devices, and VR headsets.
It's amazing how many options game developers have these days. Let's head back to agriculture for a moment. Chapter 18, Classification of Rice Plant Disease. Using machine learning technique, explores how AI can be used to detect diseases in plants.
This chapter focuses on rice, which is a staple food for billions of people around the world. Plant diseases can really devastate crops, leading to food shortages and economic hardship.
So how can AI help with that?
Well, they're using image processing and machine learning to analyze pictures of rice plants and look for those visual clues that indicate disease.
So it's like training the AI to be a plant doctor, but instead of using a stethoscope, it uses images.
That's a great way to put it. They use techniques like background removal, noise removal, image segmentation, and feature extraction to get those images ready for analysis.
It's like they're cleaning up the photos and highlighting the important parts for the AI to see. And what algorithms are they using to classify the diseases?
A few different ones. Support vector machines, random forests, and of course those convolutional neural networks again. CNNs really excel at this type of image analysis.
So it's like giving the AI a magnifying glass to look for those subtle signs of disease. What are some of the challenges in building these systems for agriculture?
One is getting those big, high-quality data sets of images that show all the different diseases, and then the algorithms need to be really good at telling those diseases apart because sometimes the visual symptoms can be quite similar.
So it sounds like you need both agricultural expertise and machine learning know-how.
Absolutely. But the potential benefits are enormous. Earlier disease detection, targeted treatment plans, and ultimately healthier crops and a more secure food supply for everyone.
That's amazing. But let's take a step back and think about how far AI has come. Chapter 19, History of Machine Learning, takes us on a little journey through the evolution of AI.
It's a fascinating look back at the history of this field, tracing the key ideas and breakthroughs that brought us to where we are today.
So where does this story begin?
It starts back in the 1950s with things like the Turing test, which was designed to see if a machine could exhibit intelligent behavior. That's when those early learning algorithms were being developed.
So they were laying the foundation for modern AI back then. What were some of the early breakthroughs that really pushed the field forward?
Well, there was the development of the perceptron, which was one of the first artificial neural networks inspired by the human brain, and those early decision tree algorithms and expert systems.
It sounds like they were trying to figure out how learning worked, both in humans and in machines. What were some of the big challenges they had to overcome in those early days?
Computing power was limited back then, and they didn't have access to those massive data sets that are so crucial for training AI today. And then there was the fundamental challenge of just understanding how learning happens.
It sounds like they were true pioneers. When did things start to shift toward what we think of as modern AI?
A few big things happened. The development of backpropagation in the 1980s was huge. It's a crucial algorithm for training neural networks. Then came support vector machines, or SVMs, in the 1990s. And of course, the rise of deep learning in the 2000s really changed the game.
So much happened in a relatively short amount of time.
Right, and the applications have exploded too.
Self-driving cars, facial recognition, medical diagnosis, you name it.
It's truly amazing to see the impact of this technology. But Let's look ahead now. Chapter 20, Startup Landscape Analysis on Internet of Things, dives into the world of the Internet of Things, or IoT.
The IoT is already having a huge impact, connecting all these devices and generating tons of data. What are some of the key trends shaping its future?
They talk about the increasing use of edge computing, which we discussed earlier. Also, blockchain is becoming more integrated, offering better security and data management. And then there's 5G, which offers the speed and bandwidth we need to support all those connected devices. Of course, data privacy and security are becoming even more important as more personal data is collected.
So the IoT is this complex and dynamic world. What are some of the opportunities and challenges for startups in this space?
The opportunities are huge. We're talking about billions of connected devices, which means a huge demand for innovative products and services. Plus, there are more and more open source platforms and tools that make it easier for startups to get started.
Sounds great, but what about the challenges?
Well, you need people with expertise in areas like hardware design, software development, data analytics, and cybersecurity. It's a really demanding field.
So it's not just about having a cool idea, you need the right skills and knowledge to make it happen.
Exactly. The chapter emphasizes that collaboration is crucial. Startups need to work with each other, with bigger companies, even with research institutions.
It's like everyone needs to join forces to make the most of the IoT.
Right, and we need to think carefully about the ethical and societal implications of this technology, especially as it becomes more and more integrated into our lives.
That's an important point. It's not just about the technology itself, it's how we use it.
Yeah, it really is about the bigger picture.
For sure. So we've covered a lot of ground here exploring all these different facets of machine learning, but I'm curious, are there any lingering questions in your mind after this deep dive? Anything you're still pondering?
Well, one thing that keeps coming back to me is that balance between automation and human expertise. We see AI automating things that used to be exclusively human territory, like diagnosing diseases or reading handwriting. So as AI keeps getting more powerful, I wonder, where do we fit in? Does AI augment us, free us up to focus on higher level tasks? Or does it eventually just, replace us?
That's a big question, and honestly, I don't think anyone really knows the answer yet. It's like we're standing at this crossroads.
It really does feel that way sometimes.
And the decisions we make now will determine what that future looks like. What other questions are you wrestling with?
Well, there's the issue of unintended consequences. Every time we make a technological leap forward, there are always these ripple effects that we didn't anticipate. We've seen it time and time again throughout history. And with AI, the potential impacts are even greater. So how do we even begin to anticipate those unintended consequences?
Yeah.
How do we make sure that AI is used for good and doesn't just worsen existing inequalities or create new ones?
That's a really important point. It's like we're building this incredibly powerful engine, but we need to make sure it has brakes and a steering wheel so we can actually control where it takes us. Are there any other thoughts that are keeping you up at night?
One final thing that I keep coming back to is that question of explainability. A lot of these AI systems, especially those deep learning models, are often described as black boxes.
Black boxes, huh?
We can see what they're doing, the results they produce, but we don't always understand how they're arriving at those decisions.
Right.
And that lack of transparency can be a real problem, especially in areas like healthcare or finance, where trust and accountability are so crucial. So how do we open up those black boxes? How do we understand that reasoning behind the AI's decisions?
That's a crucial point. If we're going to let AI make decisions that impact our lives, we need to know how those decisions are being made. It can't just be magic. Well, I think that wraps up our deep dive into the fascinating world of machine learning. We've covered an incredible amount of ground.
It's been a whirlwind tour, but I feel like we've only just scratched the surface.
There's so much more to explore. What's one final piece of advice you would give to our listeners as they continue their own journeys into machine learning?
I'd say stay curious. This field is constantly evolving, so there's always something new to learn. And don't be afraid to get into the technical details to really understand how these algorithms work. But don't lose sight of the bigger picture either. Think about the implications of this technology, the ethical considerations, the potential impact on society, and think about how you can use your knowledge to make the world a better place.
That's fantastic advice. The future of AI is being shaped right now, and every single one of us has a role to play in making sure it's a future we can all be proud of. Keep learning, keep exploring, keep asking those tough questions, and who knows, maybe you'll be the one to make the next big breakthrough. Thanks for joining us on this deep dive.
At
We'll
the
see you
end of
next
this
time.
podcast, please share your thoughts on the book, and if you enjoyed this content, don't forget to like and subscribe for more.